Hey, what's up guys, Jeremy here. Let's talk about the singularity, joint limits, and reach limits avoidance feature included in the Curve project. Let's get started. When trying to follow a complex path with a robot, there's a few mechanical traps that you need to avoid, mainly the singularities, joint limits, and reach limits. The Curve project includes some features to help you do that automatically. Let's take a look. So here under optimization parameters, you have some features to avoid automatically those traps, if I can say, by rotating the tool around the z-axis. This station here is not necessarily the best suited to showcase that kind of feature, so we will open the files here, and under CFP optimization parameters, we will open this here. Perfect. So this station is very simple. We have a KUKA robot, a tool, and then 3 simple paths. So if I open here the valid path, I can run the valid path without any issues. So if you don't know what singularities are, I have a tutorial specifically on that topic in module 7, so I would recommend you potentially taking a look so that you better understand what we are trying to avoid. Mainly when doing some milling or curve following project in general, the more common singularity you will face is the risk singularity. So when joint 5 of the robot reaches 0, or when joint 4 and joint 6 are aligned. Here with this path, we don't have this issue. Like, as you can see, the risk is always what I would call broken. So we're always, in this case, under 0. So we don't reach the threshold of going from one side of the joint 5-0 to the other. We're always in the negative space like that. So there's pretty much nothing that needs to be done in this path here. So what you can do here if you want is to see here, you have the option to allow a z rotation of plus or minus a certain value by step of a certain value. If you know that the path doesn't have or shouldn't have any singularities, you can just enter 0 here. That will kind of shut down this feature. And if you update, you will still see the green check mark. One of the advantages of doing so is that it will reduce the calculation time of your program. So here you're kind of reducing the weight on RoboDK. So that's very cool. Even with 0 here, this not activated, if I can say, you can still follow your path properly. If I go for the second path here at the top, I created it exactly where I know I will be reaching a singularity. So if I enter 0 here to allow a tool Z rotation of plus or minus 0, so that means that I don't allow RoboDK to have any room to work. It needs to follow the path with the right orientation. That's it, that's all. If I click update, I will have a next here telling me robot cannot reach all targets in the path. That means that I can start the path, but at some point there's something wrong with it. If I click on simulate, here it stops exactly here. I'm gonna move that to the other side here. If I double click the robot, you can now see that we are at -3 on the joint 5, and we started at like -35. So we are going towards the 0 threshold, or 0, the place where we don't want to be. And then at some point here, RoboDK will stop us before we reach it, because under tools, options, and then motions, we have a tolerance to avoid risk singularity of 2.5. So therefore, if I was to try to move one step further, I would hit the threshold of plus or minus 2.5. So it's stopping us before. Just like that. And if I try to run here the program, it would stop us here because the algorithm didn't kind of compute the rest of the path. So that's great and not great at the same time. If I was to enter here 180, you see, like that, click update. Now I have a green check mark. If I click simulate, I'm gonna press stops for a second. Nope, stop. I just want to slow that down so that you can better see what's going on. I was already at 1. Okay. I'm just gonna slow that down here so that you can better see what's going on. Update, simulate. If we zoom in, you will see that as soon as we reach the point where we would hit that singularity, RoboDK rotates the robot by increment of 20 degrees. So if I was to move that to the side here and just use the scroll bar here, and you look at here the joint 5 value, I start at minus 34 point something. As soon as I reach almost 0, so I'm at minus 3.5, bam, RoboDK will rotate 20 degrees, so putting me back to minus 24, continues, rotate 20 degrees, putting me back to minus 24, and then so on. So that's one method to avoid the singularity. You might say that doesn't work at all for me. I need to keep my line straight. I'm kind of cutting with a blade. I can't just rotate around. If you can't rotate around, you absolutely need to put that to 0, or maybe just giving yourself 1 or 2 degree of wiggling, if I can say, room. Some application doesn't fare well with that feature. For machining, generally that doesn't matter much. You already have your tool that is spinning. For polishing, same thing. You might say, yeah, that was a bit rough as a rotation. Fine, you can drop that here to 10, update, and then simulate. This way you won't be rotating as much between the points, but you might be rotating more often because you need to do more correction. Another way that can work, so here you can see that we have a whole lot of points crammed together. So the point here is that you will rotate 10 degrees between 2 points. So if you want to kind of expand that, what you can do is right click here, you can split curve, set point spacing, and you can say, hey, okay, I have 10 millimeters. If I go for 100 millimeters, click OK. So I have way less points on my path. If I click update and simulate, it will do the rotation, but between 2 points of 100 millimeters. So the rotation will be about 1 degree per centimeter or 1 degree per half inch. So that will be way smoother here. Or you can say, I just want to have like 20, still want to keep 20, click update and then simulate. And this way here you will have a 20 degree rotation, and then you won't have any rotation for a good portion of the path, and then another rotation, and that's it. So you can kind of work around that by changing the distribution of points in your path. If you only had here points, set point spacing, if I go for 1 meter, click OK, I think I will have only 1 or 2 points. Can't remember how long this is. I will have the rotation taking place all along the path here. So I will have my 20 degree rotation from one point to the other. So it's super smooth as a rotation, but I have a bit less control on when it's happening. So that's something I can do. I'm going to show you other example where you can kind of split the curve here and do your translation or rotation here, and then do another straight part here. There's ways to kind of go around that. Now I need to show you another super cool feature. If you go to the last one here, path out of reach, if you click on show estimated tool path here, you will see a bunch of green tools. I didn't show you that, but if I go back to the show preferred toolpath, if you bring your mouse on top of the show preferred toolpath and you use your scroll wheel, you can kind of scroll from one point to the other. If you use control and use scroll wheel, you can either increase or reduce the number of tools you will have along the path. So that kind of helps you. Same things goes for show estimated toolpath, but this one, instead of just trying to show you what you're trying to do, it will also show you if the path is actually reachable. So if I add a few more tools, let's say like that, I press Alt to move that frame here, and I move it further, you will see that at some point, some tools become red. So when the tools are red, it means that this point isn't reachable anymore. You're out of the reach. If I double click the robot and just activate the show current workspace, you can see that you're already at the limit of the workspace. So that's possible that you can't reach those points. If I bring it back forward, here I can reach. Perfect. That's awesome. Don't need to show that anymore. It will also use the rotation here. If I go to the last point here, you can see that now this point is reachable, but it requires RoboDK to rotate around the z-axis to reach that point here. And if I was to move that outward, by the way, for that to work when you're moving, you need to have the auto update activated, otherwise it doesn't work. So this is the only time I have automated update activated, is if I want to move that and see the position. So you see at some point here, this is out of reach. It tells you you can't reach all targets. And then if I move forward, it gives me a tool that is a green tool, but rotated. And if I move forward again, it will kind of reorient the tool properly. Great. So that's everything I wanted to show you for this video. We will use that briefly in the next video, where I will talk about starting point. So starting point and, let's say, robot configuration are very important when you're trying to do such paths. So we will discuss how we can kind of combine the optimization parameters with the preferred starting point. So I really hope to see you there. In any case, have a great day, guys.